wherever you are, we're going to start on letter C. And what I'm going to ask you to do is, if you're comfortable with the process, will you raise your hand and give me a next step? Nick, you want to start it? Yeah, replace what's inside that angle with A, and then write just the tangent of. Okay, now that's on the unit circle. As of tomorrow, these values won't be on the unit circle. So what do I then do? Yeah, I'm going to, in this case, solve for A. A is pi over 6. And to start out, how do I want to write these? Pi over 6. Yeah, write out that general solution. Write out that general solution. And then, one question that keeps popping up is that enough for tangent? Is it? Do I need to write a second one? Why not? Partly. Yeah, to get to the next one, right? When I think about the graph of tangent, any given solution will only hit one time during a period. I want to know when this is equal to root 3 over 3. There's no upswing, downswing for cosine or sine. So therefore, it only hits root 3 over 3 in one spot. It doesn't matter what value you're going for here, it's only going to hit once. If you follow that, raise your hand. Okay, so if you heard what Stephen said, if I add pi, that's how I would get my other solution anyway. Another reason why I don't need to list it. What do I now need to do? Someone else. Well, yes, I'm going to multiply by 2, but that's because, and I'm going to use this phrase, I substitute back in. I substitute theta over 2 back in for A, and what do I do to both sides? You heard him. What did he say? So this is theta equals, this is pi over 3 plus 2 pi k. Now, if I were asking for the general solutions, I would be done. So if you want to, like, there was a lot of confusion first period as to whether or not, or what answer went with what interval. These are my general. Does it answer the question 0 to 2 pi? No. So what do I do? What do I technically do to this? I add 2 pi, which would be 6 pi over 3, but what happens there? It's too big. Therefore, this is my only answer. Okay, now, that's probably the easiest. How is letter D different? I'm going to do what Nick said again, and I'm going to call theta minus pi over 2. I'm going to call this A, but how is this different? Sorry, that's an A. How is this different? What is different about A that wasn't there before? Hey, I hear chatting. I'm just not sure if I hear answering of questions. There's a phase shift on this, right? So my phase shift is going to have to be taken into account here in a second, but it doesn't change the process. I replace what's in parentheses with an A. I then solve for A. What's my answer? Pi over 4 plus pi k. I go ahead and I write the general. A little bit. Then I go ahead and I substitute back in. So I've got theta minus pi over 2 equals pi over 4 plus pi k. What's my next step? Okay, so now here's where it gets a little dicey. When I add a phase shift, does that change my period? No. So my theta is how much? 3 pi over 4 plus pi k. Now, if you're with me, raise your hand on that. Oh, nice. Okay. So I'm adding 4 pi over 4. Yeah. So I get 3 pi over 4, and how much would I have when I add pi? Is that okay? Yes, those are both my answers. Yeah, sorry. Okay. Now, in a minute, we're going to combine both things at once. Nick. Yeah, it's because of the interval I'm asking to solve on.
Oh, like the actual question.
Yes. Yes, correct. That's right. That's right. Yeah, sorry. I took it.
So it'd be like 2 steps. It'd be like 2 steps.
Mm-hmm. Yeah. So as an example,
So it's not the period, it's the question.
if right, yes. Okay, so zip it please for a minute. Look right here. Let's look really quickly so we make sure we really understand what that is asking. I've got tangent of x as my normal. So I want to know when this equals 1. You can see this is from 0 to 2 pi. It only hits how many times? Twice, but we know this is a period away. You with me? Okay, so if I add on the tangent of x minus pi over 2, all that's going to do is shift it. How many times does it hit? Twice. So notice there's still, you can even tell from this picture, they're the same distance apart, right? They're the same, they're still pi apart. They've just been shifted over a little bit. Now, that's going to be pretty dramatically different from letter E. So, the process does not change. And if I were to emphasize something that I just felt like first period kind of abandoned, it was like they saw these as all separate steps and separate types of processes. They shouldn't be. What's the first thing I should do? Call A, theta over 3 minus pi over 4. I said yes, I really have no idea what you said, actually. Okay, so now what do I write?
Why do you do that?
Because I think it's a lot easier. No, you don't have to, but for most people, that's less intimidating than that. Okay? So, how many times will cosine hit 1/2 in a given period? Twice, right? Where are they? Pi over 3. Now, for consistency's sake, what am I going to write immediately? Plus 2 pi k. And then where's the other one? You could call it a sub 2 if you want. 5 pi over 3 plus 2 pi k. Now, that should feel consistent. There are 2 this time, which is annoying, but the process is the same. Call A the junk inside, solve for A. Now what do? Substitute back in, right? Because what is A? Theta over 3 minus pi over 4. And then I want to put a line there just so we don't get confused. I've got 2 things that I'm going to solve here. All right, now, what is my, let's just go from a solving perspective. Let's deal with a sub 1. I got to get theta by itself. What do I do? Add pi before that. Oh, it does. Think about it like SADMAP, right? Old school algebra. You do PEMDAS backwards. You would subtract and add first, and then multiply. Okay. So for the record, if I add pi over 4, I'm repeating myself. Does that affect the period? No. So this is theta over 3 equals pi over 3 plus pi over 4. What is that? 7 pi over 12. Plus 2 pi k. Next step. Does that affect the period? Absolutely. So this is theta equals, this is 7 pi over 4 plus 6 pi k. Now don't worry about that for a second. Just consider that your first, if I ask for it, general solution. You with me? Do I mean what? Oh, okay. Yeah, so you could have 21 pi over 12. That just reduces to 7 pi over 4. Is that better? Okay. Okay. For now, I'm going to leave it. And so to just answer what maybe is some people's questions, that was definitely first period question, what do we call that kind of solution right there? That's your general, right? Because, and I'll show you in a minute, but this is your downswing answer and all the ones, the infinitely many that occur before and after it. Okay, now, on the other side, for a sub 2, what do? Add pi over 4. Okay, so I'm going to add it here and here. I get theta over 3 equals, so I'm going to do that, 12, 4, 20, 20,
23.
I believe you. Someone, I
Yeah.
is that right? 3, it's 20 on top, 3. Yeah, okay. Okay, are we okay? Yep.
If you multiply by 3, you know it's already gonna go over 2 pi. So can you just stop?
You can. That's fine. I'm going to play it out so the people, because I don't know that everyone will see that, but yes. Okay, so then my last step would be to multiply by 3. So theta equals, this is 23 pi over 4 plus 6 pi k. Now, did you hear what Ellie just said? Okay. This is way over 2 pi, right? If I add 6 pi, that's way too far. If I go back, I'd be subtracting 24 pi over 12. Or sorry, 24 pi over 4. You see what I mean? You got to go both ways. That just is flat not going to work. Okay, on this one, 7 pi over 4 is doable. But if I add 6 pi, is that going to help? No, way too big. If I subtract 6 pi, way much smaller. This is my only answer. My final solution to this, even though I found two general, my general would be here, and let's do this. Let's take this off for a minute. If the other one that we solved here would be 23 pi over 4 plus 6 pi k. These would be my general. But on the interval 0 to 2 pi, that's my only answer. Emily. Because one is coming from, because sometimes, well, two things. First of all, you're going to deal with cosine, and you have to consider the downswing answer and the upswing answer, right? Down here and up. Two distinct solutions. Right, correct, good. Charlie. Okay, all right, so I think it helps to see this graphically. So I'm going to put this in one more time. And the one thing, there's going to be a part of your test, especially next week, part of which, zip it, part of which is calculator and part of which is not. So I encourage you, when you do get your calculator, to use it. I want to know, when is this equal to 1/2? So just to say again, on a given period, typically cosine will hit a given value twice. Now, are there exceptions to that? Name them. What's a y value that cosine hits only once in a period? I heard it. -1. If I said how many times it equal to -1 on a period, you should only tell me once, right? But almost every other one is twice. Well, now if I take that exact same concept and say, you know what? My original equation is x over 3, is it minus pi over 4? Minus pi over 4. Notice, so it's the black curve here. It's this one, this top one, because I realize they all kind of blend. How many times does it hit 1/2? Just once. You see that? Now, if we were to back this up so that I could see a little bit more of the picture, I'll show you what I mean. Let's say I were to take this instead and go from negatives, let's go even 10 pi to 10 pi. You don't have to do this, but it might give you some context. Well, now, here's my, you can see this blue right here is infinitely hitting your 1/2 over and over and over again. But if I get rid of that for a second, here's the actual graph. Notice this goes out all the way to 10 pi. So it only hits 1/2 twice from 0 to 6 pi here. Do you see that stretch? Okay, so you can use your calculator to help you. All right, now, as you can see, so first period I was going to originally squeeze in more, but even with you guys, that took all but 6 minutes, right? So these are your medium level questions. I want to show you what your homework is tonight because I had to change gears from first period, so I instead posted it on Schoology. So if you go into trigonometry part 1, I posted this. You can either print this off or you can do the whole thing on a separate sheet of paper. It doesn't matter. Some of these will go relatively quickly. But the key is, hey, who's ever humming? Don't care. So some of these will go really quickly. Others of them will take a little bit longer. So I want you to see, you see number 2? What are my first couple steps? I'm going to, no, careful there. Add 1, then divide by 2. Okay, that order matters. So add 1, divide by 2, that's just a really quick solving. Also pretty quick, but I'm going to address this with you so that you can get them correct. Look at, you can write this down in your notes if you want, but look at number 4 for a minute. If I have 5 cosine of x minus root 3 equals 3 cosine of x, how do you think I'm going to solve that? What do you think I have to do first, Stephen? Yeah, get your Trig's functions on the same side. Well, how many cosine of x do I have? I have 2. 2 cosine x minus root 3, and then what would I do? Add root 3, divide by 2. Okay? Now, notice a lot of this, and I was talking back there a minute ago with people, this is just algebraic steps, right? This actually has nothing to do even with trig at this point. So just don't overcomplicate things if you don't have to. What about number 6? What about number 6? 4 sine squared minus 2. Yeah. Add 2. Yeah. Hey, can you, the extra? Just stop, okay?
What do you do with the extra?
Good question. So you still want to get the trig function by itself. So I'm going to add 2, divide by 4. Sorry. So that's 1/2. Then I what? Square root. Okay, now the only catch is, you got to be really careful here. This is sine of x equals, well, first of all, when I get the square root, how many answers do I have? 2, plus or minus. And then it would seem as if I have the square root of 1/2. Yes, that's really 1 over root 2, square root of top, square root of bottom. What do we know this value as? Root 2 over 2. And then you solve. Okay?
The positive and the negative?
In reality, it's going to be every quadrant. Yes, what's the
Whoa.
So pi over 4, 3 pi over 4, 5 pi over 4, 7. Okay.
We just print out that worksheet, or we have to
You can just do it on the sheet of paper if you want.
I already have all of them?
No, I had to change gears with what I was going to originally give you because they didn't go. The key is, you actually know those values, like from your quizzes, right? So you can do it that way, that's an option. Or you can write 1 over sine equals whatever that value is, and then flip both sides. Okay. Yes, I am for sure recording.